Hello there. N and our team created a guessing game application using C++ programming language. We created our own header file named bst.h. The header file is just pure prototypes of the function under the created bst class. The definition of the functions that we created is on the bst.cpp file. We have functions here like search, insert first, insert second, insert below, print in order, print per order, print post order, traverse, and many more functions. The binary tree was the data structure that we used in the program. In our main file named testbst.cpp, we include all the headers that we used, including the one that we created. We also declare the bst class so that we can use it. We wait for the user input and then we call some function from the class. Our program will run in a loop until the user will stop the game. My teammates will discuss the use of each functions. Thank you.
In this function, search out. If the sub-tree is equal to null, it will return false. If the item is lesser than the data, call function again, but pointing to the left child. Else if item is greater than the sub-tree data, call the function again, but pointing to the right child. Else, return true. In this next function, insert aux, just create a subtree root. And the function insert aux. If left side, then call function again but pointing to the left child. Else, point it on the right child. Let's go to the insert first function. Create as the user input question, then create a node. Then set answer to left child and create a right child. This is the insert first function. Let's go to the insert second function. Just like the insert first function, you just do the same thing, but the difference is set the answer to the right child.
Insert below function. It is when the preceding question was not met. When this happens, it requires the user to create another criteria or question that will be attached to the earlier one. Insert function. It invokes the insert aux function. Insert function. Another insert function. It invokes the insert function but with a location. Remove function. When an item is found, this function returns the exact location of the said item and it will be deleted. Then it sets the right children as the new root. Aux graph function. Displays the data in the tree arranged from left to right child respectively.
In this function, it will search the whole tree with the condition if data is not found and the node not pointing to null, then it will pass the following condition. If item is less than the data, it will go to the left child. Else, if the item is greater than data, then it will go to the right side. Else, the item has been found. These functions are the printing order sequences. In the print pre-order aux, if subtree is not pointing to null, then print data. Then call the function again but pointing to left child, then after that go to the right child. In this in order aux, it will follow the in order sequence from left to root to right. In this post order functions, it will follow the order sequence from left to right to root. And these are the functions that print the order sequences with its corresponding printing sequences. In the print pre-order, it will call the pre-order aux. The print in order, it will call the print in order aux, and the print post order aux, it will call the print post order aux. And with this constructor, it will set the root to null. And in it will set root to null also. In this function, it will call the search. It will invoke the search aux function. In graph, also with graph, it will invoke the graph aux function. In the function test, it will set all variables A, B, check, and check 1 to 0, and then invoke the traverse function.
So hello guys, I'm here to discuss the traverse function. This is for part of the tree. So we have the string answer here, Z, A, for asking if it is. So if A is equal to 1, then it will ask the question, is it A? So A is set up to 0, and it will see out the answer to show the actual question. So if B is equal to 0, then it will get the answer. Else if B is equal to 1, then answer is equal to null. If answer is yes, then if root left is not null, then A is equal to 1. Then check plus plus for checking. Then traverse, call the traverse function again. Another left, it will go to the left side. Then else the computer will win, then B is equal to 1. Else if answer is equal to 0, is equal to no, it will go to the right. Check if the right child is equal to null, not equal to null, then it will increment the check, then call the traverse function again, but this time on the right side. Else then the computer will give up, B is equal to 1, then if check is equal to 1, it will insert below the root, so it will become a part of the subtree. Else if check is equal to 0, check now is equal set to 1, then insert first. So this will be the first part of the root, so this will become the root. Then as if check is equal to 1, then it will be the second part of the root tree. So thank you and God bless.